Okay, so intro to probability. First of all, I have to know this. The probability of an event is a number between 0 and 1. It could be 0, it could be 1, or any number in between. That indicates the likelihood of an event occurring. All right, so if the probability, say probability, is equal to 0, and this P is representing probability. Probability equals 0 means this is an impossible event. Can't occur. Here, the probability is equal to 1 means the event is sure to happen. All right, so if it's in between there, it just depends on how close it is to 0, how close it is to 1. It represents how likely it is to happen. All right, so anyway, that's probability. You typically write that as a whole number. You can actually write these as percentages. So if we wrote 0%, that would be 0.00%. If I had probability of 1, that would be 100%, and so forth. So we can also think about them as percentages as well. So you can either or. You can go with whole numbers, which would be decimals, or you can go percentages. All right, moving on. All right, so theoretical probability means that, just any probability we can think of that's not a true experiment. So theoretical probability basically means it's always equal to the total number of possible events on the bottom, and on top of this fraction should be the number of desired events. So it's the number of desired over all the possible outcomes. So that's a theoretical one. And example for that, and whenever in doubt, whenever you're confused and you get stuck and the question gets really confusing, go back to this. It always boils down to the number that you desire over the total number of possible outcomes that could have happened. So some of these questions might get confusing as you get harder and harder questions, but it always boils back down to this formula. All right, going on. First example. All right, so this is the first example. You're rolling a 6-sided die, and die is singular for dice. So you're rolling a 6-sided die. What is the probability that you will roll a 4? So think about a dice. It has sides at 1, 2, 3, 4, 5, 6 on all the sides of one dice. So you think about that. Remember, it's a number of total outcomes underneath the number of desired outcomes. So this is the probability of rolling a 4. All right, so think about that. The total number of outcomes you can have. If you roll a dice or die, you got 6 different outcomes. 6 different things happen. You can roll 1, 2, 3, 4, 5, or 6. Our desired outcome is a 4. There's only one number. So you only have one desired outcome. So the probability of that is 1 out of 6. Give a new example using the same question. All right, suppose I ask the same question. I ask, what's the probability of rolling an even number? That's a number sign. So what's the probability of rolling an even number? So are the numbers 1, 2, 3, 4, 5, 6. 2 is even, 4 is even, 6 is even. So you got 3 possible outcomes to be even. So it's my total number underneath my desired, and I'm desiring an even number. So it's 3 out of 6. Or you can say 1/2. So it's basically a 50-50 chance that you roll an even number, theoretically. Now, if you actually did an experiment there, you might find there's a different outcome. But theoretically, it should be a 50-50 chance. And one more question using the same question. All right, suppose I asked you, what's the probability of rolling a number less than 7? Just think about all the numbers on a dice or die. You got 1, 2, 3, 4, 5, and 6. All those numbers are less than 7. I could roll any of those numbers and still meet the requirement. So if that's the case, you got 6 possible outcomes. 6 of those outcomes are less than 7. So it's a 100% chance. So probability of 1, or 100% chance you're going to roll a number less than less than 7. So it's sure to happen if you roll 1 dice and you're looking for a number less than 7. That would always happen. All right, new example. Okay, new example. This is probability involving permutations and combinations. So this is the question. You have saved 8 songs in your phone's playlist. You set the phone to play songs at random. The phone plays all 8 songs without repeating. What is the probability that the songs are played in the same order they are in the playlist? All right, so that's the question. I'll pause the video, write that question down, because I'm going to actually have to erase this, actually do the math for it. I'll pause the video, write down this question, and then after you unpause it, you'll see my explanation for it. All right, so the question asks, what's the probability the songs are in the same order as the playlist? So let's first think about probability. It is total possible over desired outcome. So think about all the total possible outcomes. We have 8 songs. So if you have 8 songs, how many ways can you rearrange 8 songs? That's 8 factorial. So think about total possible outcomes, 8 factorial. So it should be 8 factorial on the bottom. And my desired outcome is 1. There's only one way I can get that order, which is to match the same order. So it's 1 out of 8 factorial, which is 1 divided by 4, 0, 0, 3, 2, and 4, 0, 3, 2, 0. And that's about 0.000248. So that's what it is. As a percent, you move the decimal space over twice, it's about 0.0248%. But yeah, that would be it. It's a pretty small number. It's a pretty small probability of that actually happening. All right. But just to be clear, if I move the 0 over twice, this would come over here, and that would be, if it was 0.000248, the decimals here, as a percentage, that would be 0.0248%. If you want to write it as a percentage, just so you know. All right, going on, new example. All right, last example, and this deals with experimental probability. We've got a chart here that talks about internet users, and this is the age of them, under 21, 21 to 40, 41 to 60, and so forth. And this is the number of internet users that go by those ages. So the question is, what is the experimental probability that an internet user is 21 or older? An experimental probability means that we don't have all the data in the world. We did an experiment, and this is enough to prove it with the experiment we have in hand. So if that's true, we want to find the probability that it's 21 or older. So again, it's total. Hold up. So it's total number of outcomes underneath the desired outcomes. So I'll first figure out my total number of outcomes. So I can get 16, 36 plus 6, 6, 1, 7 plus 3, 3, 9, 3 plus 49, 1 plus 6. That's a huge number. So that number is 12, 4, 12, 4. The number is 12,443. All right, desired number is the number of people over 21. So that's this one. So that's all of these people, all of these people, all of these people, and all those people. And I add those up. If you add those up, that total should be 1636. So that's 1636 over that huge number, and that final answer is about 0.13. So the number is about 0.131, or you can think about that as about 13.1%. And that's it. That's all I have. Good luck.